Alright, we have a standard counting Sylow argument. Prove that if the order of G is 132, then G is not simple. Okay. We'll let the order of G be 132, and assume for the sake of contradiction that G is simple. Okay, we'll also spell out that 132 is the same thing as 2 squared times 3 times 11. Okay, because we want to do Sylow analysis on this. By the Sylow Theorems, N, the possible number of Sylow 2 subgroups, well, let's see. Let's actually start with 11. That's easier. Okay, the possible number of Sylow 11 subgroups, it has to be congruent to 1 mod 11, and it has to divide 4 times 3, which is 12. So 1 is a possibility, 2 is not, 4 is not, 12 is a possibility. For the number of Sylow 3 subgroups, it has to be congruent to 1 mod 3, and it has to divide 44. So 1 is possible, 2 is not, 4 is possible, 11 is not, 22 is possible, and 44 is not. So it's just these 3 numbers, and the number of Sylow 2 subgroups has to be congruent to 1 mod 2, and it has to divide 33. 1 is possible, 3 is possible, and 33 is possible. Whoops. By the Sylow theorems, we have these. Since G is assumed to be simple, we can throw away the 1s, essentially, and the number of Sylow 11 subgroups is equal to 12. Hence, there are 12 times 11 minus 1, equaling 120 elements of order 11. Further, well, we can rule out 22, because if there was 22 Sylow 3 subgroups, then 22 times 3 minus 1 is equal to 44 elements of order 3. However, 120 plus 44 is equal to 166, which is greater than 132. So this is impossible. Hence, the number of Sylow 3 subgroups has to be 4. Thus, we'll count the elements again. 4 times 3 minus 1 is equal to 12. Sorry, is equal to 8. Notice that 120 plus 8 is equal to 128, and 132 minus 128 is equal to 4. So there are 4 remaining elements. This forces the Sylow 2 subgroup to be unique, because we have 2 squared, 4, and there are 4 elements left. So this forces the number of Sylow 2 subgroups to be 1. Hence, the Sylow 2 subgroup is normal. This contradicts the fact that G is simple, therefore G is not simple. Quick counting argument with Sylow theorems.